Hi guys, welcome to our very first STAT20 walkthrough videos. The ed specialist will be sending these out roughly every week just to help you get some outside practice and to understand the concepts that we covered in class a little bit better. So we're going to start by doing the conditioning handout. This is going to be really important for you guys in the lab for flights, and also just some general housekeeping RStudio stuff. So let's get started. We're going to open up RStudio and I'm going to upload it from my downloads. This is probably how you're going to do it as well. And I have it up, so it's going to rewrite it. But we're just going to open it from our files, and here we go. So this is going to be source. I'm going to turn to visual just so that you guys know how it looks like on your end. We're going to start by just running these two lines, library and tidyverse. They are the end all be all for stats. You have to have it in every QMD file, otherwise everything is going to break. So I'm just going to run that really quick, and it'll come up in the console with some fun things. But on top of that, we also need to load up the package that we're working with. So this will differ for labs, and for this worksheet in particular, we're going to be working with Palmer penguins. I believe it's just that. And we're going to run that as well. So the reason why we run data penguins is so that it shows up in the environment here, and as it loads, it'll pop up with a little button that allows you to see it in the tab. But for now, let us just run the code that's already given to us as our ggplot. And if this doesn't work for you, try re-uploading the file, because this is straight from the notes on the website. Okay, so we have our environment and our little data frame that says penguins. So from here, we will do question 1. So extract a data frame that excludes the Adelie penguins. We're going to use this code chunk. It's this little green button, and this just allows us to see, what is code and what is text, and make it a little easier to visualize when you're working through labs. So when we first do this, we're going to look at the plot. As you can see, there's a bunch of different colors, a legend for what those colors mean, and some clusters. So when we do a data frame that excludes the Adelie penguins, we want to reference the original plot and make sure everything lines up. So let's get started. We have to run the penguins data frame, and this tells R that we are working within penguins. And the pipe operator means that every function that we run after it is going to be applied to the penguins data frame. So since we want to extract a data frame, we have to make a new one. So I'm going to call this penguins2 and use the assigning operator. And this is just going to make a new data frame, as you'll see shortly. So next, we want to extract a data frame. So we're going to use filter. Filter is essentially a function that erases observations based on conditions that you set for R. So we're going to do filter. And since we're piping this, we don't need to write penguins again. But if you were trying to nest, then you would say penguins here. We're not, so we can get right into what we want to filter for. Because we want to exclude the Adelie penguins, the easiest way to do this would to call this variable name, and we can double check it here in the data frame. It's called species, and this is where all the Adelie shows up. So we're going to say species, which is the variable, and then the exclusion logical operator. So this exclusion logical operator says that, hey, R, I want you to go through this penguins data frame and remove all the observations that say Adelie. So we're going to say species does not equal Adelie, and it's going to remove all the Adelies. And then when you run that, it's going to pop up in our environment as penguins2, and you will see that none of these species are going to say Adelie. So that's how you do question 1. Now on to question 2, extract a data frame that excludes the Adelie penguins and retains penguins with bill lengths between 40 and 50 mm. So we're going to focus on this first part of the question, because this is how we're going to get the data frame that we want to work with. If you read into these kind of lengthy word problems, you want to see a chronological order. So I know that I want to exclude the Adelie penguins, and then from those penguins that are left behind, I only want the ones with bill lengths between 40 and 50. So we're going to start with our code chunk again. And because we already took Adelaide's out for penguins 2, we're going to work with that data frame. So penguins 2 and the pipe operator. Now we have to use filter again, but now we want to have penguins with bill lengths between 40 and 50. So again, specify the variable that we're working with, and it's going to be bill length mm. And then our operators, which is going to be less than 50 and bill length greater than 40. And so when we run that, it's going to show up here as our new penguins too. So a key thing to note here is that when you do this filter, it's not going to update penguins 2 in the same way. If you check here, your bill length is like over 50, right? There's still those variables that are over 50. And that is the whole importance of updating your data frame. So let's call this penguins 3. And if I read it correctly, here you go. It'll show up as penguins 3 here. Now, since we have our bill length sorted for those only between 40 and 50 mm, we'll do another pipe operator, or actually, we're going to call up penguins 3, since filter needs to be just run by itself, and then pipe that into a arrange function. The reason why we do the arrange function is because of this second part of the question that asks it to be sorted in decreasing order by bill length. So we're going to do arrange and then decreasing bill length. Oh. And if you get this error, most of the time it's just because you forgot a parentheses like I did. Perfect. So now you have it in decreasing order of all the bill length, and you can tell that there is no value over than 50. Right. I hope that helps for question 2. We'll move on to question 3 now. Okay, so now for question 3, again, start up a new R chunk. All right, calculate the mean bill length and bill depth for each of the 3 species of penguins. Do those statistics line up with the penguins plot above? So this is one of the questions where we're actually going to have to reference this, but you'll see that in a little bit. Let's just get started on making our data frame. So when we do this, of course, we're going to work with penguins. They're not saying that you want to work with the excluded like Adelaide data frame or the ones with the ones with bill length between a certain range. So we're just going to work with penguins, simple and easy. We're going to do our pipe operator as always. And then now we're going to group by. Group by is essentially very similar to filter, except instead of taking out observations entirely, you're going to kind of find characteristics in the data frame that are very similar, and R is going to kind of categorize them together. This data frame is very easy to do that because obviously we have 3 groups. We have Adderley, Chinstrap, and Gentoo. So we're going to use group by as our functions, and we're going to say species. And this is going to make it's going to look the same, honestly, when you run it just by itself. But what it will do is that it will allow you to do following functions to operate on groups instead of individual rows or observations. So that's when we do summarize. So summarize is your go-to function for finding mean, for finding standard deviation. And this question is asking for the mean bill length and bill depth. So as always, summarize has this certain formula where you have the name of the column that you want to choose. So I'm going to say mean bill length equals 2, and then the function that I want to do. So I want to do mean bill length mm. And then the fun thing is that in summarize, you can do multiple means. And this is important because after you run summarize, so let's run that really quickly, there is no other variable. It's just going to be mean bill length because that's a new table that R is spitting out for you. As you can see, it does it for each group of species. So if you did something like this, where you did another summarize column and you try to do like mean bill depth equals to mean and then try to run that, it's going to error because because build depth is no longer a variable in this new table. So how do we fix that? We take out this other summarize and we just tack it on to the original one that we had. And let's run that. Perfect. So now we have mean build depth and mean build length for each of the species. And the second part of the question asking, do those statistics line up with what you see in the penguins plot above? Let's check it. So Adelie has a mean build mean build length of 38.8 and a mean build depth of 18. If we scroll up, find the Adelie. So Adelie's over here, mean build length was about 38.40. It's over here, so that's good. We're in the red. And then build depth was around 18, so that looks about right. That looks like a mean to me, and we did this correctly. All right, now on to question 4, which Jake will take over.
All right, so we're going to be working on question 4 right here. It's asking us to make a new metric called bill size, which is the sum of these two things. And we want to find the average and standard deviation of bill size among species and island. And then we're going to arrange that data frame so it's decreasing by average of the bill size. So this question is kind of asking a lot of different things. So a good way to break it down is the way that I kind of do it in my head, is I just kind of go through the question and find each part and just map that to some sort of function in R that you'll be able to use to accomplish it. So the first one, new metric called bill size. It's the sum of the length and depth. Anytime it's asking you to create a new metric based off of other things, it's a good indicator to use mutate. Next one says average bill size and standard deviation among each species and island. So I'm going to skip the average and standard deviation part. We're going to go to among each species broken out among islands. Whenever it's saying like, what is some statistic grouped by this or broken apart by these things, that is a good indicator to use group by. So we're going to be using group by. Eventually we're going to have to group by species and island. The question is asking. Now we can go back where it's asking for average and standard deviation of bill size, which pretty clearly would be summarized because we're taking the summary statistic. And then lastly, it's asking us to sort our data frame in decreasing order. So that pretty clearly is also a range. Any sort of increasing or decreasing, sorting is going to be the range function. So now we can start. First of all, make sure your data frame is loaded in. I already did that earlier. So type out penguins, use your pipe operator. If you don't want to type that out every time, you can do Control-Shift-M, and that is just a shortcut to show that out for you. It takes a little less time. So first thing we're going to do is I wrote it down here. I'm going to mutate. And we want to create bill size. It's going to be equal to the sum bill length and bill depth. Cool. Now we have it mutated. I'm going to pipe this new mutated data frame into group by. Group by. It says island and species. So you can just do that in one argument. Here. And now that it's flagged with group by, now we can take summary statistics. We're using summarize. And we can take the mean. I'm just naming it mean here because it's going to help later on. It's going to, make working with these data frames easier. If you just name it something, mean is just a pretty easy name. So you want to take the mean of bill size. And we also want to do standard deviation of bill size. Again, naming standard deviation column at C just to make it easier. Cool. Now we have the summary statistics. And we want to sort in decreasing order by average bill size. It's a range, like I said earlier. And since it says decreasing, we're going to use ESD here. And then average bill size, that would be this column here, which I just named mean. So decreasing by mean. Now let's run all of this. And there we go. So there's two things that are wrong with this. First thing is we have two entries here that have both NAs. We have, this permutation NAs here, this permutation NAs here. So a good way to get around this, and this is good practice in general, every time you're taking some sort of summary statistic, you should add the argument NA.RM equals true. And what that's doing is every time when you're computing this and it sees this argument here, every value that is an NA that's being used in this operation, it just takes it out. So any NA that would be used to calculate the mean of bill size is going to be removed from the data set to calculate the summary statistic. And then you're going to do the same thing with the standard deviation, NA.RM equals true. And now let's rerun it and see if that fixes it. And yes, it does. Now we have numbers here. Cool. And the other issue here, the question specifically asks for 9 pairs of statistics, and we only have 5. So number 9 comes from there's 3 species and 3 islands. So there's 9 different permutations of species to island. But we only have 5. And a lot of people were asking me this in class earlier, why this is 5, but the question is asking for 9. The answer doesn't actually lie in here. It lies in the original penguins data set. And basically, all it is, there are just some permutations of species and islands that just don't exist. So, like, there are some penguins that don't live on certain islands, and that's why they don't appear here, because that there are just no entries that, that correspond to those. So, if you're having trouble with these types of questions or you're getting errors and stuff, a really good way to debug is to just break up every time you use a pipe to make sure you're doing like what you think you're doing as just like a quick sanity check. So for example, if you think your issue is in your mutate, for example, run everything up to mutate, not including the pipe, just to make sure. Okay, did my mutate work correctly? And then in this example, yes, it did. I have bill size right here. Everything works fine. Or you think it's your issue with group by or summarize. So you run everything up to summarize just to make sure, is it working? And then I already checked this earlier, but yes, it is working. So that's just a good way to debug it, is just run it line by line, because that's how these pipe operators work, right? We're taking penguins, putting it into mutate, putting that into group by, and then we're putting this grouped into summarize, and now we're putting this new summarize into a range. So you're going step by step, and a good way to check what's going wrong is to just check each step individually. Yeah, that's how you would go about this question and just overall questions similar to this that you're going to see on your flights lab.